Also, when you do have the point, what was it? Oh, I missed it. Anyway, when we speak of electronics, it's important where most of the boys out there have some fidget fingers who wants to break something and make it also at the same time. I would
think
definitely...
it extends to girls as well.
Is it?
Yeah, it's not the boys.
There are a bunch of girls who actually do that. But then there is the point where kids also get themselves involved when it comes to electronics. The question is, what age do they start this? What is electronics and how complicated is this? Or how easy is it and what's the future of it is like? We have two experts to speak to us on that. We have Dr. Ajit Pasquale, the head of Department of Electronic and Telecommunication Engineering from the University of Moratuwa, and he's also the Director Center for Information Technology Services at the University of Moratuwa. And we have Mr. Amila Cabral, who is at my far right, who is a PhD student at the Department of ENTC. Good morning to you.
Good morning.
Thank you very
to everybody
much.
And to audience as well.
Thank you very much for joining us.
We're
when
gonna
it comes
probably
to dive
straight into the questions, Doctor, and if that's okay. So electronics and engineering is the framework we're going to be questioning you on, and perhaps get your insight onto it. So to start off, we just wanted to identify, I guess, the significance of electronics and telecommunications, and if you can introduce it to the audience, exactly what is electronics?
Okay, if I to in simple language put what electronics is, I think pretty much everybody, I believe, familiar is electrical circuits. You have a household electrical circuit, and electronic circuit is a similar electrical circuit, but it has some what we call active components or semiconductor components, which allows you to control the electronic flow or current the way that you want, and that controllability actually gives you enormous power. Enormous, like for example, if you give a very weak signal, it may be a signal that is picked up by this microphone, and you can amplify it and actually produce a amplified sound. And so this simple phenomena of this amplification and also a little bit of more controllability actually gives electronic circuits enormous power in controlling many things. So in a nutshell, actually that is an electronic circuit. But if I go a little bit further and say, because now the society actually takes it for granted what electronics is, but exactly without knowing exactly what electronics is all about. And probably we will not be having this program, and also the audience will not be actually seeing us live if not for these two fields, electronics and telecommunication. So we are actually all this, for example, these sophisticated cameras, television, all these things are there thanks to this particular field of electronics and telecommunication. And if I ask you a question, like, is there anyone in Sri Lanka, for example, maybe whose life is not touched by electronics? It will be very difficult to find that, because if you look at it, virtually every family has a TV today, and a mobile phone or a radio, the previous generation. And so these are thanks to, so what we are seeing them today in today's context, actually thanks to electronics. So that would be a bit of summary of what electronics.
You hit the nail on the head, so to speak, and it gave us a bit of
and
perspective.
iPad that you are looking at is
everywhere
the electronic device.
Some sort of technology, Doc,
Yeah.
isn't it? Amle, just on to you. Just wanted to ask. So you're in the field. You're doing a doctorate in electronics. What inspired you? What made you get into the field of electronics?
Actually, when I was at grade 1, I happened to get in touch with wires, batteries, and motors and stuff.
Right.
All
You
those
were only
stuff.
6 years old then.
Yeah, and then, yeah. So I was playing around with those stuff.
Okay.
And first, at the time, I was able to drive a motor and turn on a LED or light bulb. And I saw some programs on Rupahani that there were some documentary programs. Actually, they were foreign programs. So they were teaching teaching electronics for grade 6 or 7 students. So I was looking at them and identified that they are teaching some new stuff. So I want to be like that. So on that one program, they told the audience how to make a electromagnet out of a nail and a wire. So I did the experiment at my home. So after that, I got inspired, and it was able to attack all the iron stuff. So that I was inspired by that.
You were, yeah, very gadgematic then.
Yeah,
Just breaking things and
And
making.
I'm sure there must be a larger audience out there as well who also try out stuff like this.
Absolutely.
Doctor, I want to come back to you and ask now. The Sri Lankans, like very rightly you mentioned, each person has a mobile phone. Sri Lankans tend to have 2 mobile phones as well, and the circuits of having every mobile phone, when there's a point where they probably drop a bit of water onto it, and then they open it up and they try to fidget it around and try to do all kinds of stuff. What's the growing trend when it comes to school children taking a step into electronics?
So if you look at it, okay, the pathway to electronics. So how do I really, what Amila, catching up on what Amila said, okay, if he develops interest in electronics at the school level, so what steps are, what pathways are there for school children to go into a more detailed, getting advanced knowledge? So if I look at it, the possible ways, there are 3 paths that I see clear paths. One is obviously through the traditional school system, where you go to the GCE level and then advanced level physical science stream, and then get into the state university system. And we all know, not because of the fault of the students as such, we have very limited opportunities at the state university system. So those who actually get the appropriate marks get enter into the faculty of engineering at 3 universities. Now there are 5 universities having engineering faculties. The main 3, Moratuwa, Peradeniya and Ruhuna. That's one path. I would say a bit difficult path, because you need to actually go through the A levels, and which is a filtering process. That's the only thing that we have at the moment for filtering, unfortunately. The second one, those who are not able to make it, I mean, they don't need to consider them unfortunate as such, because there are the other opportunities as well. One such opportunity is where, if you look at electronics, there are various levels that we need actually expertise. You need designers, you need actually people who really do hands-on work to build certain things, and for maintenance type of thing. Or, I mean, we need a hierarchy. If you look at a pyramid, okay, we need at the pyramid, there are certain levels that the people want. For electronics also, the pyramid is the same. You need the high level top people, and also the middle level, the lower level, all sort of things are required. So the university pathway is one. The other one actually is the technical colleges. So there are many technologies in this country. Then each province, I think there's a technical college, the bigger one, and that path also leads to a degree also. That's the University of Vocational Technology. Ultimately, you get the technical, whatever the diploma level, and you can actually take the diploma into the degree level to the University of Vocational Technology, and there are some other paths as well. Then the third one, I would say that is a little bit costly, but those who can afford it, there are many higher education institutes coming up, and obviously the quality will be varying across the institutes, but there are options. So those who are interested in electronics, I think these are the three main streams, avenues that you can actually get into the, I would say, get in depth really into the electronics.
Right. Okay. That was a very clear answer there for you to say how to get involved and how to get yourself into that stream. So that gives us an idea.
There was parents out there who's watching the morning show right now, and if you have felt the understanding that your child is into electronics, probably fidgetive, and you want to force themselves into various other trades, we have explained a solution for you, because these are various avenues that they can get their hands on. Amila, I want to ask you, as a PhD student, you have understood the stages of every circuit, and also having had the experience of working in every stage of education. Tell us about the side of the study. How does it work for you?
Actually, the thing is that if you really need to learn the electronics, you have to do maths really well, definitely. And you have to be good at
it be 100%?
No, not need to be 100%. You have to know the basic mathematics.
The
foundation of the mathematics, as well as the science. So, and at that time, at the school curriculum, we had in science we had biology and physics stuff, all those stuff. So what I was focused on, especially the electronic part of the subject. So I was thorough at that, and I was referring some other books that I got from the school library. So I had my learning curve. I had my personal learning curve on that. So I found out what are the technologies available, what are the current trends, and all that. So when I was studying at the school, that is my learning curve.
And with your doctorate, then where do you want to end up? I mean, what's your study about? If you don't mind telling the audience what exactly your
Aim is.
aim is on that.
Actually, my PhD is about generalized vision processor development. Actually, let's say in simple terms, what I do is we have video, we have photographs, and before we transmit those videos capturing from those cameras, and before we before we take after we taking a photograph, there are enormous processes that undergo before if we want to transmit that, we have to do a lot of processing. So I am developing some algorithms and systems that make the processing part easy for the design of the camera manufacturer and the design of the broadcaster. And let's say there's a company that design broadcasting systems. So my product is embedded onto it.
The back end of
Yeah.
the system is
Yeah.
where you come in, and I think
Yeah.
the most vital part before
Yes.
it comes up to us as consumers, it starts with you, and then that idea then evolves into something you can market and becomes a brand later on. So that's where you aim to go. Doctor, just moving back into, I guess, university and your faculty in particular, could you tell us a little bit about the program?
Before moving, I just want to touch on one thing that Amila has mentioned,
Yeah.
particularly this interest in science and technology. I think one of the prerequisites, if someone actually wants to move into the electronics, is you want to actually get interested in what exactly science is, how things are working. I mean, explaining natural phenomena and using experimentations and logic. So you need to understand what exactly science is and how you differentiate science and technology. Technology is pretty much, if I say, application of science and engineering. Engineering is again application of knowledge to produce something, and also it's a field of study on its own as well. So I mean, the first thing I think we should look at from country perspective is to see whether we can actually have different programs to attract students into technology, because that is a easier way of attracting to electronics, not electronics as such, but to technology. So you see, for example, like robotics, okay, and if you have seen, let's say 2 generations back or even now, maybe a lot of people school kids might be using it, what we call amateur radio, say ham radio, and those are various methods, mechanisms of actually attracting the students into technology. So I think that we need to start there and getting the interest, and then
So
moving.
that's to encourage and motivate them at
Exactly.
a young age.
Exactly. Now the amateur radio is being taken over by, for example, interest in electronics, interest in robotics. So we have actually we brought one sample.
Actually, I can show you that. Actually, this is a small product. Actually, this is called a development board, microcontroller-based development board, and these boards are being used for designing small robots and large-scale robots. So this is a microcontroller. Can you see? And the thing is that this product is developed by A&T Labs. It's a company that is formed by two of our university graduates. So these boards are capable of driving robots from very low end to high end. So and there are some other boards where you can purchase. Actually, earlier the problem was that we were unable to purchase high end development board from the manufacturer. We were unable to buy high end development boards. We only was able to buy through internet. But in Sri Lanka we did not have that facility. So there are some companies like Lankatronics, they sell those boards. Actually, these boards as well as foreign development boards, and from that students can get hands into these boards. This is very easy to learn. These are very simple boards, and you know
I wouldn't go that far as simple. You might be testing us here. We want to ask us a few questions. I'm sure it is simple in your end. I think we're privileged as Sri Lankans to have a university as Moroto and individuals
There's
such as
so
yourself.
much talent there.
Absolutely, and I think not just in Sri Lanka but abroad, the demand for our students, Doctor, you'd agree with me, is pretty high. And I think we've got companies from London coming down just to nab students, and I think that must be a challenge for you. How do you retain students?
Exactly.
Doctor, and also the point where Manu touched upon, where students come, keenly are interested in Sri Lankans. We do see competitions and exhibitions where